Hey guys, happy Thursday. We're going to keep moving on today and we're going to talk about lesson 3.2a, solving systems by substitution. So first things first, please get out your binder and your bell ringer and go ahead and do these problems. I am going to not draw names today. I'm just going to ask for two people to come to the board and volunteer to do these problems and to go over them together. So pause this video and work these problems out, and then when you guys are done, come back and we'll check your answers. Okay, so I might be writing over people's work, and I'm sorry if I am, but let's look at these problems. So here we have classify. So remember, classify means where I'm saying, is it independent, is it inconsistent, or is it dependent? So to do that, we have to know what's our slope and what's our y-intercept. So both of these equations here are in standard form, so I have to rewrite them into slope-intercept form. So for the first one, I have x plus y equals 6. So I want to solve for y. I'm going to subtract x from both sides, and I get y equals negative x plus 6. So my slope of that line is m equals negative 1. My y-intercept is 6. For the second equation, I have 3x plus 3y equals 3. And I want to solve for y. So I'm going to say minus 3x on both sides equals negative 3x plus 3. And then remember, I have to divide everything by 3, not just the 3x here, but everything. So that's going to give us y equals negative 1x plus 1. So here I have a slope of negative 1 and a y-intercept of positive 1. My slopes are the same, but my y-intercepts are different. So that means that this one here should be inconsistent. All right, for this next one, both of the equations are already in standard form, so I'm going to go ahead and find the x and y intercepts. So x would equal negative 2, y would equal 1. Down here we'd have x would equal 4/3, and y would equal negative 4. I'm sorry, I don't know why there's not a graph here. I thought there was, but we'll just kind of make our own little sketch over here. So we're going to have x is negative 2, y is positive 1. So negative 2, positive 1. I thought I might have a ruler. Oh, that's not it. Okay. So I'm going to connect those with a straight-ish line. For the second one, I have an x-intercept of 4/3, so that's somewhere between 1 and 2. And then I have a y-intercept of negative 4. 2, 3, 4. So when I connect those lines, or those dots, I mean, it go like this. So when I look at where do they cross, I'm going to estimate, because I'm not going to get it perfect. But if I estimate, it's at about 2, 2. So that's what I'm going to say our solution should be. So if you didn't get those, or you need to take a moment and discuss, go ahead and pause the video and then resume the video when you're ready to move on. Today we're talking about solving systems with substitution. So graphing is not useful in every situation because it takes time. It is not 100% accurate. If you have fractions as answers, it can lead to inaccurate answers. So we're going to look at today and tomorrow 2 algebraic ways of solving systems. And today we're going to look at solving by substitution. So this is best used. It can be used anytime, but it's best used when one or both equations has an isolated variable. So I'm talking about something that looks like this, like y equals 3x plus 12, or x equals 5y minus 3. Something along those lines where you have a variable that's already solved for. Let's look at an example. So here in example 1, we have these two equations, and instead of graphing them, we're going to use substitution. The reason we want a variable already isolated is because what we're going to do is we're going to say y equals all of this. So I know what y equals. I can take what y equals and substitute it in for this y here. I'm going to get 2x plus, and then I'm going to, where that y was, I'm going to drop that and put these parentheses and everything inside in for y. So parenthesis negative 2x minus 1, and then close the parenthesis I ended, equals 3. And now I can start solving. So I have 2x, when I distribute that I would just get minus 2x minus 1 equals 3. Now this is a little bit of a tricky problem because if I simplify on this side I have 2x and negative 2x. Those cancel out and I would get 0x. But I don't want to write 0x. I'm just going to write negative 1 equals 3. With no variable left to solve for, I have to ask myself, is this true? Is negative 1 equal to 3? Hopefully you all are shouting no, because it's not. So what we're going to say is since those are not true, that means that this would be no solution. If we were to graph this, our lines would end up looking something like this, where they're parallel. All right, let's look at the next one. X equals y minus 2 and 3x minus y equals 6. I have a variable already isolated. So I'm going to take whatever x equals and put that in parentheses, and then take that, substitute it in for this x. So I'm going to get 3 parentheses and then y minus 2. And then I'm going to pick up where I left off. So notice I kept the 3. The x is the only thing I took out, and I put whatever was here in for x. Minus y equals 6. I'm going to distribute that 3 to everything and get 3y minus 6 minus y equals 6. I'm going to combine like terms. I've got 3y and negative y, which would give me 2y minus 6 equals 6. Add 6 to both sides. Divide by 2. I'm going to get y equals 6. But we're not done. This is not the only part of our answer. So remember, our final answer has to be an ordered pair. So all I know is that my y is 6. I still have to find my x value. So I'm going to take what I got for x, and I can plug it into either of these equations. It does not matter. However, with substitution, when you already have a variable isolated, I would plug it in for this one here, because I'm trying to find this value right here. So what I'm going to do is put x equals 6 minus 2. And that's going to be a little bit easier to solve, because I just get 4. Now, if I wanted to check my answer, I could take that 6 and plug it into the second equation. 3x minus 6 equals 6. If I add 6, 3x equals 12, divide by 3, and x equals 4. Same answer here and here. So that means that I did this correctly. And 4, 6 is our answer. Solve the system using substitution. So this tells us to use substitution. However, none of these have a variable isolated already. So we're going to have to solve for one variable. We can solve for this x or this x or this y or this y. It doesn't matter which one. I typically look for which one does not have a coefficient of like more than 1. So here I see like that's got a 2, that's got a 3. This is going to be my best bet. Yeah, there's a negative 1, but negative 1 is easier to deal with than having to divide by 2 or 3. So I'm going to solve this for y. When I solve this for y, I'm going to have 2x minus 1y equals 7. I'm going to subtract 2x from both sides. And I'm going to get negative 1y equals negative 2x plus 7. I have to divide everything by negative 1. Cross those out, and I get y equals positive 2x minus 7. So now I've solved for y, and I can take that, and I can plug it in, or substitute it in, to the other equation. Make sure you're not plugging it into the one you just solved for. that I can plug it in to the other equation. I'm going to have 3x minus 2, parenthesis, I'm dropping my y and filling that in, 2x minus 7 equals 10. Distribute, 3x minus 4x plus 14 equals 10. So let's do some simple algebra here. Plus 14 equals 10, minus 14, negative x equals negative 4, and then divide by negative 1. So we'd have x equals 4. We still have to find our y, because we have to find the ordered pair. I'm going to plug it into the first equation. It doesn't really matter which one I plug it into. I should get the same answer. Equals 7, so that would give us 8 minus y equals 7. Subtract 8, negative y equals negative 1, and then divide everything by negative 1. And we would get y equals positive 1. We could plug it into that other one and check. So let's say we'd have 3 times 4 minus 2y equals 10. 12 minus 2y equals 10. That would be negative 2y equals negative 2, and y equals 1. We got the same thing, so we know that we did things right. Your homework tonight is to do page 128, numbers 2 through 12 even. Have that ready for tomorrow, and send any questions that you have to me. Have a good night.